we're going to look at domain, range, and if something is a function. Okay, so we have some two-dimensional graphs that are kind of on our Cartesian plane here. We're going to try to decide very quickly if something, what the domain, what the range is. The first thing we're going to point out is this is a continuous function. So we're going to use the concept of the domain is x is the element of all real numbers such that, and we got to see how far to the left and how far to the right does it go. It looks like we have -4. That's hard to see. Yeah, -4 and +5. Okay. So our range is between -4, +5, and x is all the values in between. It looks like it's touching, so we're going to say -4 is less than or equal to x, and x is less than or equal to 5. Same concept with the range. We've got to find its highest point, which looks like it's at 6, and its lowest point, which looks like it's at -3. Range is y is the element of all real numbers such that we write the lowest number to the left, so -3, the y in between, the largest to the right. And because they touch, we say less than and equal to, less than and equal to. And that's a really quick, simple way to write in domain and range. There's other ways of writing it. I'll show you another version of it where you don't actually have to spell out y is the element of all real numbers. But the one last thing we have to check is if this is a function. Now we don't have specific coordinates. We could sit down and write them all down, but there are so many because it's continuous. What we check is for a vertical line test. Does it pass? When we draw a vertical line, does it only touch this image once? So here it looks like it does. But if we draw it here, it's very obvious that we have two distinct points where this line touches. That means this would not be a function. So not a function because it doesn't pass this vertical line test. Okay, we'll jump over to this one here on the right. Okay, the domain, same idea. Looks like it goes to -6, and this one goes on forever. Okay, we'll use a different method of writing domain. We can say the domain is, so here we have a square bracket, usually representing inclusive. It stops at this value here. So we have -6 and then comma. This one goes to the right forever, so you would say technically infinity with like a circle bracket here, saying that it goes on forever. So that's actually a really simple way to write the domain. We'll take a look at the range. It's probably similar. This value is 8. So it looks like our high point is the value of 8, and our low point, because it continues downwards, is actually -infinity. -8 it stops at, but it goes on forever for -infinity. So that is our range in this case. So -infinity, comma 8. There's a quick way to write it. This also looks like it's probably going to pass the vertical line test everywhere we go. It's going to continue that version. So this is a function. Is a function. Okay. This one here, pretty simple. Domain, it goes from -infinity to +infinity. And the range is actually just one value. The range happens to be 4. So it's just a set with the number 4 in it. And is a function, passes the vertical line test, so checks out great. This one's similar to our first one, so you just kind of jump through this list to see everything. Nothing too different. We do have some set notation, where we have the numbers written as sets here. We'll quickly check out this set for domain and range. The domain here is just a list of numbers. So we'll write them out and then we'll rearrange it. We have 5. We use all the x values for the domain. We have 5, 4, 5, 4, and -5. We don't need to be redundant. We only actually have to write a number once. So we can write from least to greatest -5, 4, and 5. That is the domain. And the range in this question, same concept. -5, -5, 5, -4, and -5. We'll condense it, put it in order, -5, -4, and the number 5. Now the tricky part here is trying to tell if this is a function. We look for x values where they duplicate. So we have 5 and 5, and it has two different y values, that would mean this is not a function, because there are two distinct y values for that one x value. We can apply the rest of this, but those are really the interfaces. We've looked at one like this before. We'll do it really quickly. They've already set you up with your domain and your range here. These are your x and your y values. Nothing's redundant. All we can do is write it as a set in order. So you could say -10, 3, 6, and 20. That makes it simple. And your range is, oh, I kind of drew over that number. I think it's 12. -11, 0, 5, and 12. That's simple. And the question is it a function? Well, right away we can tell this x value has two y values. That means this is not a function in this case.